In the jungle, the mighty jungle, the lion sleeps tonight. In the jungle, the quiet jungle, the lion sleeps tonight.
Hi, Kyle.
Hi.
What do you want for food this week? You can either have mealworms or crickets. It's your choice.
I don't really care. I like both of them.
That's weird. My teacher taught me today about indifference curves and trade-offs.
Yeah, an indifference curve is a graph that shows the combination of two goods that a person feels indifferent about. This is called utility.
Utility is the value or satisfaction that people derive from the goods and services they consume and the activities they pursue. So your utility would be how many crickets and or mealworms you eat and how satisfied you feel. Alright, Kyle, let me think a little more about what my econ teacher said today.
Okay, indifference curves. An indifference curve represents the total utility that can be gained from purchasing two goods. Any point along the indifference curve represents the combination of two goods that will add up to the total utility. You can see the slope of the indifference curves are constantly changing. This can be explained by the diminishing marginal utility. As we buy more mealworms, the marginal utility goes down. You can see the slope progressively get more parallel to the axis. And the same thing happens with crickets. As we buy more crickets, the marginal utility for additional crickets goes down and it starts to level out. Okay, next we can add a budget line. We have a total budget of $36 to buy Kyle the Gecko's food for the week. A carton of mealworms costs $1. A carton of mealworms costs $1.20. And this means that if we spend all $36 on mealworms, we would be able to buy 30 cartons of mealworms. That would put us a point right here. But we would have no money left to buy any crickets, so our number of crickets we would buy would be 0. And crickets are, say, $3.60 a box. So if we do $36 divided by 360, we would only be able to buy 10 boxes of crickets. And that'll give us our x-intercept down here, 10. Okay, so the x and y intercepts represent the maximum amount of crickets or mealworms we can buy within our given budget. And this also creates our total budget line. So at any point on this line, the cost of the combination of either one of these goods will total $36. And this can also be found by the equation total budget over price of mealworms and total budget over the price of crickets, which is shown here. Okay. The point at which the budget line is a tangent to one of the indifference curves is the utility maximizing combination. This is the most mealworms and most crickets we can buy within our budget that will still give us our total benefit, total utility benefit. We can use the slope of our line to better understand trade-offs as prices change. With an initial price of $3.60 for crickets and $1.20 for mealworms, we can buy 30 and 10. So using simple math, we can determine our slope for the price of $3.60 and $1.20 is going to be -3/1. So what this means is that if we're going to buy one more box of crickets, we're going to have $3.60 less to spend on mealworms. So mealworms costing $1.20, we're going to have to put 3 cartons of mealworms back on the shelf to make up the $3.60 we spent on another box of crickets, which represents the slope again of the line, of the budget line. Okay, now let's say the price of crickets drops to $1.20 a box. So now we have our total budget and our price of crickets dropping. So we have 36 over, let's say, $1.20. This makes, then we can buy 30 boxes of crickets too. So that will put our new x-intercept at 30, and it will make a new budget line. Which right about there. And so we have 30 meal. We can buy 30 mealworms, or we can buy 30 crickets. This is going to give us a slope of -1 to 1. So what this means is that if we're at the store and we want to buy mealworms and crickets, if we decide to buy one more box of crickets, that's $1.20 less we have to spend on mealworms. And since mealworms are still $1.20, we only have to put back 1 box of mealworms. So our trade-off is 1 box of mealworms, 1 box of crickets. Okay, and then I'll just go in here and draw the rest of the lines and come back to it. Okay, now we added more prices in. 360, 180, 120, 90. And we can see here as this price goes down, we tend to buy more crickets to reach our utility maximization, which means we demand more crickets to reach it within our budget. And we can also see the idea of diminishing marginal utility here too, because you can see that the amount of utility of crickets starts high and it starts getting lower and lower as we buy more crickets. Okay, so now if we look at our demand curve, we can see how this correlates to demand curves. Okay, so if we look here at our price of 90 cents here, we can see that we demand right at 20 boxes of crickets. So if we look up here on our price at 90 cents, we can see that at 20 crickets, we are meeting our utility maximization for that budget. And if we look at the price at $3.60, we can see that we only demand about three boxes of crickets. So if we look on our indifference curve, we can see at 360, we demand only 3 boxes of crickets to meet our utility maximization. So this is how we can derive demand curves from indifference curves, and we can also look at demand curves to get a glimpse of what quantity we need of goods to meet our utility maximization within our given budget.
See, Kyle, it's that easy.